Okay, so this is a review of solving systems of linear equations. Let's put a system of linear equations on the board, and that is y equals 3x plus 1 and x equals 3y plus 1. Now the first step of substitution is we need to solve either one of the variables, solve for either one of the variables. And in this case, we're solved for both of them. So let's choose the first one and use that to make the substitution. So wherever we see y in the second equation, instead we're going to put 3x plus 1. So x equals 3 times 3x plus 1 plus 1, right? We just plug this into here where there was a y before. Let's simplify this. We get x equals 9x plus 3 plus 1. X equals 9x plus 4. We'll subtract 9x from both sides, and that'll give us minus 8x equals 4. Is that correct? Have I done this correctly? Yes. And now to solve for x, I'm going to divide both sides by negative 8, and I'm going to get x equals negative 1/2. Okay. Again, we're not done. We have to now find y. So why don't we find y in a different color? Y just equals 3x plus 1. So y equals 3 times negative 1/2 plus 1. Y equals negative 1.5 plus 1, which equals negative 0.5, or also negative 1/2. So y also equals negative 1/2. And one thing I want to do today that we didn't do before was I'm going to actually check this, do the process of checking it. How do I check it? I just plug both values in to both equations. So let's check it in a different color. For the first equation, what that means is negative 1/2 equals 3 times negative 1/2 plus 1. Well, we just did that up here. We did that process here. And we found that that equaled negative 1/2, so that's correct. Negative 1/2 equals negative 1.5 plus 1. Negative 1/2 equals negative 0.5, which is correct. So the x, it works in the first equation. Okay. Any questions about that so far? Yes, Leah. No, now we're plugging our answers back in to check to see if we've, pardon? The substitution means is this step right here. That is, we solve the original, one of the original equations for y or x, or one of the variables, whatever they are, and then wherever we see that in the next equation, we plug that value in instead of the y. So instead of this, which is x plus 3y plus x equals 3y plus 1, we write x equals 3 times 3x plus 1 plus 1. That's the substitution step. This, what we've done in the red and in the green, is just beginning of checking it. We've only checked one of the equations. The red we have to do. The green we don't. The green we do to check our answer. Okay? And we're not finished checking our answer. We also have to check it in the second equation. Oops, didn't mean to do that. Okay. We check it in the second equation, and that's right here. So again, we have negative 1/2 equals 3 times negative 1/2 plus 1. But we know that's correct because we've done that arithmetic in 2 other places here. Okay? So this is the solution to our system of equations. Okay? Let's try another example. So for this system, we have the following equations, which are a little bit different. We have x minus 3y equals 14, and x minus 2 equals 0. Okay? What's different about these is that this equation, the second equation, doesn't have a y in it. Well, that's okay. We can have a linear equation that doesn't have a y in it. That just means it's a vertical line, and we can solve this very easily for x. X equals 2. And in fact, not only do we have the equation x equals 2, we have the value x equals 2, since it's always equals 2. So we're actually almost halfway home. We plug this value back into here to find what y is. So we get 2 minus 3y equals 14. Well, we can just solve this for y. So subtract 2 from both sides, and we get minus 3y equals 12. Or y equals 12 over negative 3, which equals negative 4. So we have y equals negative 4. Now we're done with the substitution process, but let's check it. Well, let's check it in the first equation. We have 2 minus 3 times negative 4. The question is, does that equal 14? Well, that's 2 plus 12, and that in fact does equal 14. So that's correct. But we have to check it in the second equation, which is right here. We have x is equal to 2, so we plug that in. 2 minus 2, does that equal 0? Yes. So we've solved both equations.